Hello children, this is your Kirti ma'am and today we are going to see all the chemical reactions from the chapter 1 of grade 10 CBSE chemistry, that is chemical reactions and equations. Now let us start writing all the reactions of the chapter. Okay, the first category of reactions which you have is your combination reactions, and in the combination reactions the first reaction you have is calcium oxide plus water. They both react. Please take care that you practice writing the reactions with the physical states. Okay, and obviously it should be a balanced reaction. Gives calcium hydroxide. Okay, gives calcium hydroxide plus heat. Gives calcium hydroxide plus heat. This is your first reaction, and you people know we call calcium oxide as quicklime and calcium hydroxide as slaked lime. And this reaction is already balanced. CaO is quicklime and calcium hydroxide is your slaked lime. The next combination reaction you have is carbon reacts with oxygen, which you also call it as combustion reaction, giving CO2. Okay, carbon is in solid form, oxygen is in gaseous form, and carbon dioxide also is in gaseous form. Okay, and the reaction is already balanced. The next combination reaction I have is 2 moles of hydrogen react with 2 moles of oxygen. Both of them are in the gaseous form. Okay, and what do they give? They give 2 moles of water. This is the next combination reaction. Clear? Now you have one more combination reaction. Okay, you have one more combination reaction here, which is your magnesium reacts with oxygen, giving magnesium oxide. Okay, now we forgot to write the physical states here. Here, water also will be in gaseous form. Okay, now magnesium is in solid form, oxygen is in gaseous form, and as I keep on telling you, all metal oxides will be in solid form. Now, if I balance the reaction, here it will be 2 MgO and here it will be 2 Mg. In the combination reaction section, you have one more reaction, which is not a combination reaction. It is a continuation of your first reaction. Okay, what does this tell now? Calcium hydroxide is used for whitewashing. Okay, calcium hydroxide, we use calcium hydroxide for whitewashing. Now, when you use no, this is not a combination reaction. This is mentioned in NCERT, along with calcium hydroxide, because calcium hydroxide is used for whitewashing. When you do the whitewashing, the calcium hydroxide, which is there on the walls, reacts with the atmospheric carbon dioxide. Reacts with the atmospheric carbon dioxide, forming what? Calcium carbonate plus H2O. Forming what? Calcium carbonate plus H2O. Now, formation of this calcium carbonate will give the shiny finish. Okay, today we do whitewashing. The calcium hydroxide in the whitewashing reacts with atmospheric carbon dioxide, giving calcium carbonate plus water. Now, this will give the white shiny finish to the walls. Okay, formation of calcium carbonate will give the white shiny finish to the walls. Now, this is a very important reaction which is there in your NCERT. Now, this is a base, so I take it as aqueous. Now, carbon dioxide is my gas, calcium carbonate is my solid, and water is my liquid. Okay, this is not a combination reaction, but this is given under the calcium hydroxide because it is one of the applications. Okay, now if you go for the next reaction, we have a certain category of reactions in NCERT which are termed under exothermic reactions. Okay, which are termed under exothermic reactions. Now, exothermic reactions are those reactions which involve the release of heat. Okay, which involve the release of heat. The main exothermic reaction here mentioned in NCERT is the combustion of methane. Methane will undergo combustion, okay, giving CO2 plus H2O plus heat. CO2 plus H2O plus heat. Now, if you try balancing this reaction, okay, here I will put 2 oxygens here and here it will be 2 H2O. Okay, now I think this is a balanced reaction. This is a balanced reaction. Now, along with combustion of methane, now if you go with the physical state, methane is a gas, oxygen is a gas, carbon dioxide is a gas. In this reaction, water is in the form of water vapor. So, this also will be in the form of a gas. Clear? Okay, now you can go for the next combustion reaction, which is my respiration reaction. What is exactly respiration here? Glucose. Okay, whatever glucose which is there in the in the living organisms. Okay, now I'll take it as aqueous, which because we are talking about glucose in living organisms. Now you inhale oxygen. Okay, glucose in your body, it will react with oxygen. Oxygen also we will write aqueous because it is there in the human body. It will undergo what? Glucose is there in your body. When you take in oxygen, glucose will break down as CO2 plus H2O. plus lot of heat also is produced. This is the respiration reaction, which is also a exothermic reaction. Now when you try balancing it, here I will get 6 O2, here it will be 6 CO2, here it will be 6 H2O. So these are the reactions. We have written combustion reactions. Next we have written the exothermic reactions. Okay, combustion reaction and then the respiration reaction. Both combustion reaction and respiration reaction both are exothermic reactions. So okay, when we go to the next category of reactions, okay, and exothermic reactions, they are not combination reactions. In NCERT they have given a separate, because why did they give exothermic reactions? Is most of the combination reactions or almost all the combination reactions are exothermic reactions. Okay, almost all the combination reactions are exothermic reactions. In NCERT, when it is mentioned that all combination reactions are exothermic reactions, he has given two more examples under exothermic reactions, which is combustion of methane and respiration reaction. They are not combination reactions, but they are exothermic reactions. And remember, all combination reactions are exothermic reactions. Now, when we go for the decomposition reactions, okay, now when we go for the decomposition reactions, the first and very important decomposition reaction we have is decomposition of ferrous sulfate. Okay, decomposition of ferrous sulfate. Now, this decomposition is happening in the presence of heat. We call it as thermal decomposition. And decomposition of ferrous sulfate gives us Fe2O3 plus SO2 plus SO3 plus SO3. Now, if I balance it, it is 2 moles of FeSO4 ferrous sulfate. On heating gives, okay, on heating is 1 mole of 1 mole of ferric oxide, 1 mole of SO2 gas, and 1 mole of SO3 gas. Now, here if you see physical states, this is in solid form because you are heating a solid. Okay, you are heating a solid, and this is your solid, and SO2 sulfur dioxide is a gas, and SO3 sulfur dioxide is a gas. Okay, now if you see the colors of this, Fe2O3 is reddish brown in color. Fe2O3 is reddish brown in color. And FeSO4, if it is there with 7H2O, FeSO4, if it is there with 7H2O, it is called as green. Okay, it is called as green vitriol. But initially when you heat FeSO4 7H2O, green vitriol, the water molecules will leave. When the water molecules leave, the color green color is due to water molecules. Now, when the water molecules leave FeSO4 7H2O is in green color. Now, when you initially heat, the water molecules will leave. Now, this FeSO4 is in white color, but FeSO4 7H2O is in green color. Now, I already told the color of this. This is your reddish brown. And SO2 and SO3, they are colorless gases, but they give a very bad smell, which we call it as rotten X smell or the pungent smell. Okay, they are colorless gases. When we come to the smell, how do you recognize the presence of sulfur dioxide and sulfur trioxide? Because they give a rotten X smell. This is my thermal decomposition reaction. One more thermal decomposition reaction you have in the syllabus, that is the decomposition of calcium carbonate, which you thermally heat it. And what do you get it? You get calcium oxide plus carbon dioxide. It is already a balanced reaction. When we go to the physical states, calcium carbonate is in solid form. Calcium oxide also is in solid form. Carbon dioxide is in gaseous form. Clear? We have one more thermal decomposition reaction, which is the decomposition of my lead nitrate. Okay, which is the decomposition of my lead nitrate. Lead nitrate, when I heat it, what does it give? Lead nitrate is in white color. Okay, here calcium carbonate is in white color, the FeSO4 is in white color. When you heat it, you get lead oxide. You get lead oxide plus NO2 gas plus O2 gas. Okay, plus O2 gas. Now, if you try to balance the reaction, no, it is not a balanced reaction. 2 PbNO3 taken twice gives 2 moles of lead oxide. Okay, gives 4 moles of NO2. This is your balanced reaction. Now, when you come to physical states, PbNO3 is a white colored solid. Now, PbO is a metal oxide, so it is also a solid. The color of PbO is pale yellow. The color of Pb, whenever there is a color, please remember the color. Okay, lead nitrate is white in color. Now, NO3 is a reddish brown gas. Okay, NO3 is a reddish brown gas. Okay, reddish brown gas. As you know, oxygen is a colorless gas. Now, let me write the physical states here. NO2 is a reddish brown gas and O2 is a colorless gas. And PbO is a yellow colored solid and PbNO3 taken twice is a white colored solid. No, so these are the thermal decomposition reactions mentioned in your NCERT. Now, when we go for the electrolytic decomposition, we have decomposition of water, 2 moles of H2O. Okay, 2 moles of H2O. Which kind of decomposition is this? It is electrolytic decomposition. So, which is a major factor which is leading to the decomposition of water? It is your electric current. What do you get here? I get 2 moles of hydrogen gas plus 1 mole of oxygen gas. Now, water is in the form of a liquid, because if you have to do electrolysis, it should be a liquid or a molten form or an aqueous solution. Now, I get 2 moles of hydrogen gas and I also get 1 mole of hydrogen gas. Clear? Now, when the next kind of decomposition which I have in our NCERT is the photolytic decomposition. Here we will decompose AgCl, silver chloride. Okay, now this decomposition happens in the presence of what? Sunlight. Okay, this decomposition happens in the presence of sunlight. It gives Ag plus Cl2 gas. Okay, this gives you Ag plus Cl2 gas. AgCl is a solid. Okay, silver is a solid and chlorine is released in the form of a gas. Okay, now this is my balanced reaction. Okay, this is my balanced reaction. Now, when you come to the colors of the gases, okay, chlorine is a greenish yellow gas. Okay, chlorine is a greenish yellow gas. Mostly color is not asked for chlorine gas, but it's always good to remember. Now, okay, now silver, it is in your gray color. Okay, silver is in gray color and AgCl as usual is your white colored solid. Okay, now you do the decomposition of silver bromide here, and again I will do decomposition same in the presence of sunlight. Okay, here I have to put 2 Ag here, gives 2 moles of silver. Okay, again as I told you it is gray in color, plus I have my bromine gas getting evolved here. Okay, so, Ag in solid form, silver in solid form, and bromine in the gaseous form. Now bromine is released in the form of brown fume. Okay, brown fumes. Okay, it is released as a gas, and this gas comes out in the form of brown fumes. And these four, you people know these two reactions, decomposition of silver chloride and decomposition of silver bromide, are used in photography. Okay, are used in photography. So please remember the colors of the gases and please remember the balanced chemical reaction. So these are the reactions in the decomposition category. Now let me write all the reactions under the category of displacement. Okay, displacement is what? A highly reactive metal will go and displace a low reactive metal from its solution. Now, if I take iron plus FeSO4 gives what? FeSO4 plus copper. Here, iron being a more reactive element than copper, metal than copper, displaces copper from its solution. Now, iron is in solid form. Okay, iron, okay, iron. Okay. Okay, sorry. Okay, iron is in which color? Iron nails are in gray color. Copper sulfate solution color is blue. Now this is a solution, so I'm writing it as aqueous. Now FeSO4 will be a solution. It is aqueous and copper is in the form of solid. Now FeSO4 solution color is green. Whenever I'm writing colors, please remember the colors. Okay, please remember the colors. And copper is in brown color. Okay, and copper is in brown color. Now if you take one more reaction, iron reacts with zinc sulfate. Okay, iron in solid form reacts with zinc sulfate. Zinc sulfate is in aqueous form. It can displace zinc from its aqueous solution, giving FeSO4 aqueous. Okay, plus Zn. Okay, plus Zn solid. Now here already color of iron. It is a gray in color. Zinc sulfate also is a colorless solution, and FeSO4 also will be a colorless solution and zinc will be in the form of white. Okay, zinc will be in the form of white. Wherever there are particular colors to be remembered, I'm writing them. Okay, you can check with them. Okay, iron is already gray, so I didn't write it again. Okay, Fes plus CuCl2. Okay, CuCl2 is a blue-green solution. Okay, CuCl2 is a blue-green solution. CuCl2 is a blue-green solution. Now, when this reaction happens, it will give what? FeCl2. Okay, FeCl2 from here. Okay, plus copper. Copper, as I already mentioned you, it will be which color it will be? It will be in brown color. Copper will be in brown color. Clear? Copper will be in brown color, and here the physical state is your aqueous. Okay, physical state will be your aqueous. Now ferrous chloride is almost in your almost it will show your light green kind of color. Okay, these reaction colors are not so important, but if you want to remember, you can happily remember them. Okay, clear? Yeah, now here I was telling what here zinc sulfate basically. Okay, zinc sulfate basically is a colorless solution. Okay, okay, this is a colorless solution. Now, when you go for FeSO4, FeSO4, iron is displacing zinc from its solution. So here you get FeSO4 and FeSO4 color is green. This is not very dark green, but you can see a pale green color here. Okay, but you can see a pale green color. So as such, colors are not mentioned in NCERT, but as part as knowledge purpose, if you want to remember, you can remember the colors, or else it's fun because the colors here are not mentioned in the reaction, but for these colors are mentioned in the reaction because copper sulfate is in blue color, and usually this reaction is done even in the laboratory, the first reaction. So it is always good if you can remember the colors. Okay, if you can, or else if you can ignore the colors for the next two reactions, but for the first reaction, you please try to remember the colors. Okay, now when I go for the double displacement reaction, I have barium chloride, okay, which is aqueous, okay, and I also have sodium sulfate, okay, which is also aqueous. Now in double displacement reaction, there will be interchanging of the ions. Now when the ions get interchanged, I get barium sulfate, okay, plus 2 NaCl. Okay, now 2 NaCl will be aqueous because sodium chloride is a soluble salt. Now barium sulfate, if you take barium sulfate is a solid, and it settles down in the form of a white PPT. Okay, it settles down in the form of a white PPT. This is your one double displacement reaction where you have interchanging of ions and you have a PPT formation. It's a very important reaction. One more reaction, if you okay, one more reaction, if you see, I have my okay lead nitrate. I have my lead nitrate plus potassium iodide. Okay, lead nitrate. Now it is interchanging of ions. I get PbI2 plus KNO3. I get lead nitrate plus KNO3. Now, if you see here K2NO3 here, because I have 2NO3 here, here it will be PbI2. So here I'll get 2. Okay, this is a balanced reaction, and always remember here the physical state of PbI2 is solid because PbI2 settles down in the form of LOPPT. PbI2 settles down in the form of LOPPT. So this is your aqueous and this is your aqueous, and I have already balanced the reaction. So these two are the double displacement reactions from NCERT which you need to remember. Now when you go to the last category, which is your redox reactions, the first reaction in that is you are heating your copper. Okay, you are heating your copper. Okay, when you heat your solid copper, copper is in brown color. When you heat your solid copper, it will give you copper oxide. Okay, copper gets coated with a layer of copper oxide, and this copper oxide is your solid. All metal oxides are solids, and the color of copper oxide is your back. And what type of reaction is this? This is oxidation reaction, because in this I'm adding oxygen. Addition of oxygen is called oxidation. Removal of oxygen is called reduction. So here what is happening? Oxidation is happening. I have one more reaction here. I will take the same copper oxide, black copper oxide, and when I react it with hydrogen gas, okay, and all these reactions we heat them. Okay, we heat them, and when I heat this, what will happen? Okay, I get the formation of copper solid, which is brown in color, plus H2O. Okay, H2O, which is my liquid. Okay, H2O, which is my liquid. Copper oxide is black in color, and the color of copper is brown. Here in this reaction, what is happening? Copper oxide is losing oxygen. So what is happening to copper oxide? Copper oxide is undergoing reduction. Now, whichever is undergoing reduction, I call it as what? Oxidizing agent. Whichever is undergoing reduction, I call it as oxidizing agent. Now, if you go for H2, H2 is becoming H2O. Okay, because addition here, removal of oxygen is called reduction. Now, from H2 to H2O, there is addition of oxygen. So I call this reaction as my oxidation reaction. Clear? And whichever is undergoing oxidation, I call it as a reducing agent. This is very important reaction given in your NCERT. You take your copper oxide, you pass hydrogen gas onto it and you heat it. Copper oxide gets reduced to copper and hydrogen gets oxidized to your H2O. Now, if you see here, one more reaction is there in NCERT. ZnO, zinc oxide plus copper. When they react, it gives Zn plus CuO. Now, okay, Zn plus CuO. Clear? Now, zinc oxide is solid. Copper also is solid. Okay. Now, what do? You heat it. You get what? Zinc in the form of solid and copper oxide also in the form of solid. Clear with this? Now, zinc oxide is undergoing what here? Reduction. Zinc oxide is undergoing reduction, and copper is undergoing what here? Copper is undergoing oxidation. As I told you, whichever is undergoing reduction is oxidizing agent, and whichever is undergoing oxidation is your reducing agent. The last and the final, not the last and the final reaction, we still have reactions. Now the next reaction is MnO2 plus HCl. Okay, this reaction is already balanced. That is the reason I didn't balance this reaction. Now let me go back and check if I have balanced the above reactions. Yes, the above reaction also is already a balanced reaction. Now when I see this MnO2 MnO2 plus HCl. Okay, when I do this reaction, MnO2 plus HCl, manganese oxide, when it reacts, metal oxide is a solid. Okay, HCl is an acid, so I take it as aqueous. I get what? MnCl2 plus Cl2. Okay, plus Cl2 plus I get my H2O gas. MnCl2 is a salt, so it is aqueous. Chlorine is in the form of a gas, and H2O is in the form of a liquid here. Okay, H2 is in the form of a liquid here. Now, if I try to balance this reaction, I have two chlorine atoms here. So here it will be 2Cl. Okay, here it will be 2Cl. No, it will not be 2Cl. It will be 4HCl. Because I have two chlorine atoms here, two chlorine atoms here. So here it will be 4HCl. Because I have got four hydrogens here, I'll put 2H2O here. Okay, a 2H2O here. Now I think everything is balanced. I have two oxygens here. I have two oxygens here. Four hydrogens this side. Four hydrogens this side. Four chlorines here. Four chlorines here. Here what is happening? Manganese oxide is getting converted into MnCl2, and this reaction is my reduction reaction. This reaction is my reduction reaction, and MnO2 is my oxidizing agent. Okay. Now HCl is getting converted to Cl2. In this what is happening? In this oxidation is happening because removal of hydrogen is also called as what? Oxidation. Okay, oxidation has three definitions. Addition of oxygen is called oxidation, removal of hydrogen is called oxidation, removal of electrons also is called oxidation. And for reduction, removal of oxygen is called reduction, addition of hydrogen is called reduction, addition of electrons is called reduction. Now HCl is losing hydrogen, so what do I call it as? Oxidation reaction. So H2O is okay, HCl is getting oxidized to Cl2, and HCl is undergoing oxidation, so HCl here is my reducing agent. So these are the reactions under the category of redox reactions. Now you have corrosion. Okay, now you have corrosion. In corrosion, mainly I have corrosion of copper. Okay, in corrosion, I have mainly the corrosion of copper. When you see the corrosion of copper, copper will react with atmospheric water vapor. Okay, and it also reacts with atmospheric carbon dioxide, and it also reacts with atmospheric oxygen. Okay, atmospheric oxygen. And what it will give? It will give a, okay, it will give a basic copper carbonate. Okay, it will give a basic copper carbonate. Why do I call it a basic copper carbonate? Because copper carbonate is in association with copper hydroxide. When copper carbonate is in association with copper hydroxide, I call it as basic copper carbonate, and the color of this is green. Okay, and the color of this is green. I think everything is balanced. Only I have to put two copper atoms here. Okay, two moles. I have to take 2 moles of copper here, because on the right side I have two copper atoms. And what do you call this? This I call it as basic copper carbonate, which is green in color. Okay, now when I do rusting of iron, okay, what are the necessary conditions for me for rusting of iron? Iron should be in the presence of oxygen and water. And what should I get here? Okay, I should get Fe2O3 dot XH2O. Now XH2O means what? XH2O is the number of water molecules I have in the atmosphere. Okay, now how would I balance this reaction? How would I balance this reaction? I have to put here, okay, I have three oxygens on this side. I have three oxygens on this side. So wait, okay, I will put 2 into XH2O here. I'll put 2 into XH2O here. So 2 I got here. Okay, 2 moles of XH2O. Now, okay, because I have how many here? Okay, now what will I do here? I'll put two iron atoms here. I'll put two iron atoms here. Now, is it balanced? Now, here I have two. Mm, okay, here I have two oxygens, but here I have how many? Okay, this is okay. Now, what should I do here? I will put two oxygen here. Okay, I'll put two oxygen here. So 2 into 2, 4. Okay, 4 plus 2 oxygens. Now this is fine, I guess. Okay. This is fine, I guess. Now what can I do here? I can put 2 Fe2O3 here. I can put 2 Fe2O3 here. So how many will I get? 2 into 3, 6. So here 2 into 2, 4. 4 plus 2, 6. Okay, now this is fine. Now why am I putting X? Because I really don't know how many moles of water it gets associated with. That is the reason I'm putting here X. Now here this will become 4Fe. So what will the balanced reaction of rusting of iron? 4Fe, this is very important. 4Fe plus 2O2 plus 2 into XH2O gives 2 moles of Fe2O3 dot XH2O. So this will be your balanced reaction. This will be your solid. Okay, O2 will be your gas and water will be in the form of water vapor. So I can take it as a gas. And this is your, okay, reddish brown flakes of rust, and this is my solid. If you go here, copper is in solid form, water is in liquid, or you can take it as gas because it is water vapor. CO2 is in gaseous form, and this also is in gaseous form, and this is in which form? Solid form. Clear? I hope you got, I hope you got it. This is corrosion of copper reaction, and this is rusting of iron reaction. Now you have one more reaction, which is tarnishing of Ag. Ag reacts with atmospheric sulfur dioxide, okay, and give what? AgS. okay, AgS, okay, plus your oxygen gas, okay, plus your oxygen gas. Okay, now this is in which color? Okay, this is in which color? This is in your black color. So tarnishing of silver, what will happen? Silver will react with atmospheric SO2, which is a pollutant gas. And what happens if I wear a silver article? That silver article reacts with atmospheric oxygen, okay, sorry, atmospheric sulfur dioxide, and it gets tarnished. That tarnished silver will look black in color. That black color is due to the formation of silver sulfide. Okay, that black color is due to the formation of silver sulfide. Now, silver you are wearing as ornament, so it is in solid form. SO2 is in gaseous form, and this tarnishing is in solid form, and O2 is released in a gaseous form. Okay, so these are the reactions. Okay, these are the reactions, all the reactions of the chapter, chemical reactions and equations. Hope you see, children always have a confusion on the how many reactions I have, which reaction should I be learning. So these are all the reactions which are there in the chapter, chemical reactions and equations. Hope you loved the video. Share it with your friends. Please don't forget to like, share, and subscribe. I have done my level best to put all the reaction from the chapter, chemical reactions and equations. Till I see you with the next chapters, all reactions, which is my acids, bases, and salts. This is Kirti ma'am signing off. I'll see you back in the next session.